can look at, for example, defects or observe other things that go on inside the battery as you're cycling. So this is operando. So you can do this kind of X-ray tomography or imaging. Yeah, the sort of structure, larger structure, but you can also look at quite fine detail using this technique as well. And then just final couple of slides, I thought I would mention about, artificial intelligence, AI, and automation. So of course, in industry, they're using a lot of robots to build and put together battery cells. This is quite standard. But in the lab, we're not really doing it that much until now. So there are a few projects which are starting to look at the use of robotics in building battery cells. So you can use these kind of small robot arms to pick up different components of the battery. So they're all sort of contained in these areas here. And then it will, put together the battery, fill it with some electrolytes, and crimp it together. And then it can even just put it directly to the potentiostat and start some electrochemical testing. So the idea is really to use this to accelerate battery assembly and testing. And then you can actually build a lot more batteries in a short space of time. You can use this to vary the materials that you put inside the battery. You can make different electrolyte formulations and test this quite nicely. So it's good for materials discovery, accelerating research, and then hopefully this can lead to quite high performance batteries. And there are some projects going on where you sort of take this idea of using AI and autonomous robots for materials and battery assembly. And then you collect a lot of data from these kind of testings. You can even do some characterization of battery components or do it operando even while the battery is being cycled. And then you have different sort of computational techniques and data analysis, and you end up with a lot of data and databases. And the idea is to actually really use the AI to understand what's the best material here, or try to predict what a good material would be, and then you tell the robot to go and test that in the lab. So it's quite a interesting sort of approach to battery development. So that's more or less it. So I'll just conclude with a few sentences here. So there's quite a large effort in research worldwide to develop new materials for lithium-ion batteries as well as other batteries, as I've shown you. There's a very large range of characterization techniques for the study of materials and the processes inside a battery. And these are constantly being developed, so to enable sort of operando methods or to look at specific sort of chemistries or processes. And then you've got the AI and robotic automation being developed to accelerate material discovery and to create high performance batteries for the future. So that was it. Thanks for listening.
Thank you very much, Andy. Y si alguien tiene alguna pregunta, puede escribirla por el chat. Hemos tenido algunos problemas anteriormente, pero creo que ya todos están habilitados para hacer preguntas. Y mientras van formulando algunas preguntas, Daniel, are you there?
Yes, for sure I'm here.
Okay. You know, there was a problem with the chat, so there were some questions for you.
All right.
They sent it to me.
Okay.
Okay. I will translate the questions. There are
Mhm.
two. One is, could you please explain us the difference between dendritic growth and the SEI layer?
Yeah. I think Andy can answer this as well. It's two different phenomena. The SEI layer is both of these we can say they are side reactions. It's things that you don't want really to happen in the battery. But the SEI layer, that's decomposition of salt and solvent from the electrolyte that occurs on the anode of the battery. And it's because the operating potential is very, very low. So everything there can react. And then you form sort of this very thin layer of a lot of species, and you also showed a structure of this with a different type of components. You have carbonates, you have inorganic, organic species, etc. The dendritic formation, that's metals. So it's metal dendrites that are being formed and being plated. So this is when the lithium is, instead of going into graphite, it stays on the surface and reduces and becomes lithium metal. And then it plates there ununiformly, and that is the dendrites. They can penetrate through this SEI layer. I hope this was clear enough.
Yes, it was clear. And the second question says, how can we control the formation of the SEA layer in a sodium battery? And which
Oh,
are the
what?
considerations we have to take into account to form a good layer?
Oh, this is a very good question. SEI layer in sodium-ion batteries turns out it's much more complicated than it is in lithium-ion. And so when people started to work on sodium-ion batteries in our group, we thought that the SEI layer in sodium-ion batteries, should be rather similar to the SEI layer in lithium-ion batteries. But actually, these components, when you exchange lithium to sodium, they have very different chemical stability. I mean, these components, they dissolve much easier in the electrolyte. So it's much more tricky to make a robust SEI layer in a sodium-ion battery. And the research that we have been doing in Uppsala is very much to play around with new type of additives and solvents in the sodium-ion battery system in order to try to get things that spontaneously polymerize and is stable enough and not dissolving out into the electrolyte. And another strategy is also to saturate the electrolyte with components so that the SEI layer don't really dissolve.
Okay, thank you very much for your answer.
But this is a difficult question to answer, and the reason why there are still problems with sodium-ion batteries, I would say, is also because the SEI layer there is not as well understood, and it's much more unstable than it is for lithium-ion batteries. Do you agree with me, Andy?
Yes.
Good.
Thank you very much. Todos los participantes tienen activado el micrófono y el chat, si es que alguien más quiere hacer alguna pregunta.
Yeah, me again. That question was myself. I understand how that you say, Daniel. But it's okay if I compare. Can I? No, if I can compare the lithium-ion batteries and sodium-ion batteries in specific this say layer, or it will be a bad decision.
Maybe I didn't understand the question fully. If
Sorry.
we are talking about the SEI layer again in sodium-ion batteries, right?
Yes.
Yeah. So can you repeat your question, please?
Heidi, ¿podrías repetir tu pregunta?
Sí, sí, eso, ahora sí, ¿me escuchan?
Sí,
Te lo
sí,
voy a
te
hacer
escucho.
en español. ¿Estaría bien si yo comparo el comportamiento de esta capa CI en una batería de ion sodio con una batería de ion litio o estaría incursionando en un error?
Daniel, is it okay to compare an SEI layer in a sodium battery than with a lithium battery? Is it okay to make this comparison or is a
Yeah.
mistake?
No, it's the same type of phenomena occurs. So there will be an SEI layer also in sodium-ion batteries, just like it is in lithium-ion batteries. So it's perfectly fair to compare. It's just that the sodium-ion battery have a more problematic SEI layer than the lithium-ion battery, but they are comparable for sure.
I would
Okay.
say like typically the electrolytes in these two systems are quite similar. So that's why you get quite similar sort of SEI layers. But in the case of sodium ion, then like you said, Daniel, we're trying new solvents and new salts and different things like this. So it's then you get a completely different SEI layer than you might get in lithium case.
Okay, perfect. Thank you so much.
Mm.
Thank you for your question.
¿Alguna otra pregunta?
Yes, hello. I would like to ask to Andy, when they do the XPS analysis of the SEA layer, how they identify this SEA layer prior the analysis in XPS and how they can be sure that they are analyzing the SEA layer.
Oh, that's a good question. I think Andy should answer this.
Yeah, yeah, it is a good question. It's always tricky with the analysis of XPS data. I mean, you're not seeing the signal is not saying exactly what compound you have there, so you have to do a lot of interpretation and comparison with literature or previous studies. But yeah, I mean, typically if you've cycled the battery, then you will have formed some SEI layer, and we know that. And you can see, for example, that you have this formation of a layer at the surface of the electrode, whereas it wasn't there on the pristine kind of starting material, the graphite, for example. So you see that you have something new on the surface of the layer of the electrode. But yeah, like I said, it can be a bit tricky with how you prepare the sample. So if you have a lot of electrolyte residues on the surface, then this can actually complicate things a little bit. Sometimes you might mistake some of these residues for part of the SEI, or yeah, it's sometimes difficult to distinguish what really is the SEI and maybe what's you also have the binder in the electrode. I mean, this is often has quite similar sort of signals to the SEI, so that can also complicate things. But you know, you have to do a lot of testing, and if you're studying, for example, electrolyte additives, then you might try different concentrations of additives, or yeah, so it can be a lot of work.
Thank you, Andy.
So Andy, for me, the SEI layer is really complicated. So besides
Just for you.
XPS,
That's,
I have to be honest. But besides XPS, which other technique can we use to make a study of this layer? Because which one do
Yeah,
you
this
suggest?
is a question I often ask myself as well, because yeah, I think XPS it's a good technique for studying this. I mean, it has this sort of surface sensitivity and the chemical sensitivity, but then at the same time, you also want to match it up with some other techniques which can sort of help to corroborate what sort of analysis you're doing and what results you get from the analysis. But yeah, I mean, infrared spectroscopy is one technique you could try to use. So that's what I was showing in one of the final slides, which was looking at gas analysis. So they also used infrared. But you can use this online gas analysis technique as well to study, for example, how the electrolyte is decomposing. So if you have some SCI deposition on the electrode surface, but also some gas evolution, you can try to think about what reaction processes you have and how the electrolyte is really decomposing. There's other techniques as well. I mean, you can use TEM and eels. If you have a very thin SEI layer, then you can use that. And you can use things like TOF sims. So that's but this is kind of a destructive technique. You're bombarding the surface with some high energy ions and then measuring what comes off with a mass spec. What would you say, Daniel?
Confocal Raman spectroscopy was
Raman,
used because then you can get a better focus often than with conventional IR. But it's still, I mean, you cover a much larger sort of depth with the confocal Raman spectroscopy than with XPS. It's not that surface sensitive.
Yeah.
Thank you very much for your answer. Bueno, creo que no hay más preguntas. Gustavo, por favor.
Bien, con esta actividad damos por concluida las actividades respecto de la visita de los colegas y profesores suecos de la Universidad de Uppsala, Daniel Brandel, Andy Naylor y la profesora Guiomar Hernández. Solamente decir que todas estas actividades han sido apoyadas por el BICIS de la UNSA en el marco del subprograma de materiales, nanomateriales y energías renovables. Invitamos a todos los participantes de estos días a participar en las siguientes actividades que van a tener desarrollo en este mismo subprograma, así como también en otros subprogramas relacionados a la misma línea de la cooperación sueca ASDI. Nada más, agradecer mucho también la participación de los colegas del área de química inorgánica y el apoyo de la carrera de ciencias químicas también para la realización de todas estas actividades. Les agradecemos mucho su presencia y esperamos verlos en otra oportunidad. Daniel, ¿quisieras decir algo antes de cerrar el curso? Do you want to say something, Daniel, before we close this session of courses?
Yes, it has been very rewarding for us from Uppsala to visit UMSA and the great company by Gustavo Garcia and his research team and all the other colleagues at UMSA. It has been a great pleasure for us, and also to visit this amazing city of La Paz again. It's been several years since I was here the last time. I think also the progress that I have seen being here 6 years ago and being here now is also quite tremendous, and I'm very impressed on the research efforts in the battery field at UMSA. I would also like to stress also what I pointed out during my lecture. I think Bolivia has a key role to play in global battery development, and hopefully this can also be correlated with key performances also when it comes to research in this area. And here I hope that we can continue to collaborate also from Uppsala and Sweden in this context.
Muchas gracias, Daniel.
Muchas gracias, and thanks for having us here and being so excellent hosts.
Yes, thank you so much.
Thank you very much for a lovely visit. Vamos a acabar con el curso. We have to say goodbye, Daniel, Andy. It was a pleasure to see you here in Bolivia and all the knowledge you gave us as a group. Thank you very much.
Thank you. Bye-bye.
Thanks for having us. Bye.
Bye-bye.
very much.